All right, folks, welcome back to another week of Algebra 2. We're finishing up our work with logarithmic functions this week. In particular, we're looking at how do we graph a logarithmic function. I know how much you love graphs, so I'm excited. Before we get into that, let's take a look at a record I just got in the mail. It's a loot pack record. It's a project that Madlib was a part of quite some time ago. It's pretty good. If you're into like really cool beat-based hip-hop stuff, I really recommend it. He samples a lot of cool jazz stuff, a lot of cool funk stuff, a lot of cool rock and roll stuff. It's kind of all over the place. There's a lot of music on this thing. So if you're into that kind of thing, check it out. If you don't like good rap, then don't listen to it, obviously. And if you don't listen to anything I say, then don't listen to this either. But I'd never heard it before I got it, and it's really good. Some really cool stuff. Stone's Throw Records in general puts out fantastic things. So yeah, take a look at it. Anyways, for our math, like I was saying, we're going to be looking at graphing logarithmic functions. So I hope that you remember a little bit about graphing exponential functions, because we're going to be using a lot of that to help us out. So the key thing to remember here is that exponential functions and log functions are inverses. This means a couple of things. One thing they do is they undo each other. This is why we can solve exponential equations with logs, because the logarithm undoes the exponential stuff. The other thing it means is that the domain and range, the x values and y values, are switched. So that means the x and y values switch. And we're going to see a little bit more about what I mean by that in just a minute. So to really quickly reiterate the idea between exponential form and logarithmic form, if we had something like, 3 squared is equal to 9, that's the same thing as saying that log and the base of the exponent becomes the base of the log. The answer goes inside there, and the exponent is the answer. So those two things are related. And that means that if we have our function that is f of x is equal to 3 to the x, then if we put that into its logarithm form, we use this little notation. It's f a little -1 for an exponent and then x. That means the inverse of f of x. And it's going to be equal to log base 3 of x. So still, the base of the exponent is the base of the logarithm, and then just f of x goes to f prime of x. So when we graph these logarithms, we're really going to be thinking about what does the graph of the exponential look like, and then how can we use this idea here of x and y values switching, domain and range switching, to get the x and y values that we're going to put on our logarithmic graph. So let's consider the following. For our example, let's graph log base 2 of x is equal to y. Now the first thing that I'm going to do is rewrite as the associated exponential form. Let's call it that. What that means is I'm going to say that this is actually y equals 2 to the x. Just like I said, f of x was 3 to the x, so the inverse was log base 3 of x. I'm going to do the related exponential form. And now I'm going to find some points on this. So find some points on the graph of y equals 2 to the x. If you recall, when we did this before, we usually wanted a negative x value. We wanted the y-intercept. and we wanted a positive x value. So let's just go with those again. Let's let x equal -1. Then we get y equals 2 to the -1, which according to our exponent properties is equal to 1 over 2. Our y-intercept means x equals 0. So let x equal 0, y is equal to 2 to the 0 power, which according to our exponent properties is 1. And a positive x value, let x equal 2. Y equals 2 squared, which is 4. There's no particular reason that I chose these x values. I could have done -2 and +1, or I could have done 3. But I just want to get enough points to kind of get the shape of this graph. So let's build a table here. So our x values and our y equals 2 to the x values. So when x was -1, we got y equaled 1/2. When x was 0, we had y equals 1. And when x was equal to 2, we had y was equal to 4. And now we're going to do the switcheroo part. We're going to switch x and y. That's our third step here. So we're going to have x and then y is equal to log base 2 of x this time. And we're just going to switch them. So we had -1, comma 1/2. So let's switch it. The -1 goes in the y column, and the 1/2 goes in the x column. We had this point, 0, comma 1. We're going to switch it. The 0, which was in the x column, now goes in the y column. The 1 now goes in the x column. Our last point that we found was 2, comma 4. Again, let's switch it. That 2 that was an x value is now a y value. That 4 that was a y value is now an x value. And now we have points that are on the graph of the logarithmic function. So let's draw out an xy axis here. I'm gonna put it kind of in the middle of the page so we can still see this table that we made here. It's not gonna be perfect, but it's gonna be good enough. We got 1, 2, 3, 4, 5, 6, 7, whatever. We got 1, 2, 3, 4, -1, -2, -3, -4. And let's plot these points. 1/2, -1. Go to 1/2 on the x, down to -1 on the y. 1, comma 0. Over to 1 on the x, 0 on the y. And then 4, comma 2. Over to 4 on the x, up to 2 on the y. And we're going to connect these things with a smooth curve. All right, so there's a couple of last details that we're going to put in here. So let's remember that f of x equals 2 to the x had a domain of x such that x is a real number and a range such that y was greater than, not greater than or equal to, excuse me, that y was greater than 0, and we had a horizontal asymptote at the line y equals 0. So if we think back to what we said at the beginning of this lesson, where exponential functions and logarithmic functions are inverses, and that for inverses, the domain and range are switched, so the x and y values switch, we're going to apply that here and know that the same things apply. That means that for f of x equals log base 2 of x, instead of our domain being all real numbers, it's going to be greater than 0. So our domain is the set of all x values such that x is greater than 0. And if you look at our graph, that's exactly what's happening here. Our range was bigger than 0 for the exponential, but we're going to switch it. So it's going to be all real numbers. So it's the set of all y values such that y is a real number. Again, if you look at our graph, that is exactly what's happening. We're going down to every possible y value here, And it looks pretty flat here, but it's actually going up very, very slowly. So we're gonna hit every y value going upwards too. The last thing that we're gonna switch is this x and y too. So instead of having a horizontal asymptote at y equals 0, we're going to have a vertical asymptote at x equals 0. That's this line here that we're never gonna cross. And that should, in a sense, make sense, that we cannot put negative values inside of this logarithm. Why? Because if we convert back to our exponential form, like if we try to evaluate log base 2 of negative 3 equals some value, putting it in our exponential form, 2 to the x equals negative 3, but we just said that all of our outputs, all of our y values, for an exponential function have to be positive, so we cannot get this. So that's why our domain is x is bigger than 0, and our vertical asymptote is at x equals 0. Now it's worth noting that this is not exactly true for every log function. We could do a transformation or a translation of the graph. We can move things 4 units to the right, or 3 units down, and 2 units to the left. We can dilate things, we can reflect things. But for the basic graph, our domain is x is greater than 0. Our range is all possible real numbers, and we have a vertical asymptote at x equals 0. All of the dilations, all the translations, all the transformations work exactly like they did with every other function. If you have any questions as you go through the Desmos activity, please feel free to reach out to me via email or leaving a comment on the Google Classroom activity, and I'll try my best to get back to you. I wish you luck with all this. I miss seeing each of you in class every day and doing math with you. That is far superior to making these videos once a week at home. But I hope that you're all doing well. Please tell your friends to watch math videos and learn math because it's awesome. Please check out Loot Pack and all the good music that I recommend to you because I would never tell you to listen to something bad. Have a good one.